Hi everyone, today my group members Zhongdui, Jiaheng, Aldina and I will be discussing about what the topic real-time operating system and multiprocessor operating system is all about. I will start with a brief introduction about operating systems in general. Operating systems, or more commonly known as OS, are the backbones of modern computing systems. They essentially provide a stable platform for software applications to run on hardware while also providing the necessary interface between software applications and hardware. An OS is a piece of software that controls how the resources in a system is used and also performs various essential functions, such as managing security, scheduling tasks, and handling errors. Today we will be mainly talking about these two types of operating systems: real-time operating systems, or more commonly known as RTOS, and multiprocessor operating systems, or MPOS. The first OS I will introduce is Real-Time Operating System. It was developed to support applications that must handle a lot of events with a strict timing constraint. This type of OS is commonly used in embedded systems such as air traffic control systems, autonomous driving systems, and other applications where real-time responses are critical to the functionality of that system. Real-time operating systems also usually provide mechanisms for handling interrupts and exceptions in real time to ensure that the system can respond to critical events with minimal latency. Some other features they may come with consists of synchronization, inter-task communication, task scheduling, and interrupt handling. This is to ensure that the tasks are completed within the time constraint given. Next up, I will introduce the multiprocessor operating system, or commonly known as MPOS. It was developed to support computer systems with multiple processors that work efficiently together to execute a single task. The way they do this is by dividing a task amongst themselves for a faster execution. When the task is done, results are collected from the multiple processors and compiled to give the final output. The design of a multiprocessor operating system is commonly used in operating systems such as Linux, Windows Server, IBM ZAC OS, and Solaris. These operating systems are then commonly used in servers and systems that require high-performance computing power, such as database servers, a collection of high-performance computing systems, and web servers.
Hi, I'm here to tell you about the background of real-time operating system and the multiprocessor operating system. So, what is about real-time operating system and multiprocessor operating system? RTOS is an operating system with two key features: predictability and determinism. In an RTOS, repeated tasks are performed within a tight time boundary, while in a general-purpose operating system, this is not necessarily so. The next is MPOS, used in operating systems to boost the performance of multiple CPUs within a single computer system. Multiple CPUs are linked together so that a job can be divided and execute more quickly. When the job is completed, the result from all CPUs are compiled to provide a final output. I'll explain why there are needs for such technique. First, let's discuss about real-time operating system. First one, resource optimization. A real-time system are often resource constrained, which means they must use resources such as memory, processing power, and network bandwidth as efficiently as possible. And RTOS provided machine for resource allocate and manage that are efficiency. Second, fast response time. In a certain application such as medical devices or airspace system, fast response time is critical, and RTOS includes mechanism and ensure that the system can respond to event and perform tasks in real time. Last one is the improved reliability. Real-time system must be reliable and free from error, and RTOS offer that required procedure and ensure that the system function correctly and that faults are noticed. Processor operating system. The main reason of using multiprocessor operating system is to improve overall performance of the system by utilization multiple processors in a parallel to execute tasks. The operating system can manage several jobs at once when there are multiple processors because it can divide up tasks among them. This could increase the system overall speed and efficiency. Another reason is for using a multiprocessor system is to improve the reliability and fault tolerance. A multiprocessor system can also contribute a system to increase scalability. Additional processor can be added to the system to manage the increased workload and application processing need grow. By allocating tasks to the most efficiency processor and contributing overload among the available processor, the operating system can manage to extra resource. For the real-time operating system. First, industrial automation. Real-time operating systems are commonly used in industrial automation systems. They are help to control process in a real time, monitor sensor, and able to high-speed data communication. Second, medical device. Real-time operating systems are used in a medical device to ensure the accuracy and reliability of critical functions, such as monitoring vital signs and control life support system. Third, automotive system. Real-time operating systems are used in automotive systems to control critical functions such as engine control, anti-lock braking system, and airbag development. Next is a multiprocessor operating system of implementation. First, HPC, as known as high performance computing. Multiple processor operating systems are commonly used in HPC cluster, where they are enable multiple processors to do work together on a single problem, such as scientific simulation or large-scale data analysis. Second, server virtualization. Processor operating systems are used in a server utilization to enable multiple virtual machines to run simultaneously on a single physical machine, providing a greater resource utilization and improved efficiency. Database system. Multiple processor operating systems are used in a data system to improve query processing, transaction management, and other critical functions by allowing multiple processors to work on the different parts of database simultaneously. This slide is discussed about sample of product. For real-time operating system, we have a source space and defense system, and Automotive system, aerospace and defending system. Aerospace and defending system such as missile, aircraft, and radar system require an RTOS to ensure precise timing and respond to an external event. An RTOS can ensure that key operating systems such as controller and communication are done within a specific time constraint. Automotive systems to guarantee an activity are carried out within a certain frame. Automotive system including anti-lock brake system, electronic stability control system, and engine management system needs an RTOS. An RTOS can ensure that the control duties of this system are done correctly and timely, boosting safety and reliability. What about multiprocessor operating system product? First, Linux. Linux is an open source operating system that can support multiple system processors. Number 2, Microsoft Windows Server. Microsoft Windows Server is a commercial operating system that supports multiple processors. It is designed for use in a server environment and it includes features such as failover clustering and load balance. Third, macOS. macOS is an Apple operating system that supports multiprocessor. What is the application of real-time operating system and the multiprocessor operating system? Real-time operating systems are designed to control processor with a premise timing constraint, and RTOS are often used in a system like industrial control system, ventilation system, and medical device are required quick data processing and reactivity. Multiple processor operating systems are developed to operate computer with a server CPUs. These systems are used in computer aided design CAD, computer aided manufacturing CAM, and other computing applications. Where is it being used? Industrial Control System RTOS is used in industrial control systems such as programmable logic controller PLC and distribution control DCS. These systems are require premise timing and respond to external events to ensure that industrial processes are executed efficiency and reliability. Robotics RTOS is used in robotics to ensure premise timing and control of robotic systems. This is essential for applications such as factory automation, medical robotics, and space exploration. Last, automotive system RTOS is used in automotive systems such as anti-lock brake system, electronic stability control system, and engine management system in order to ensure the safe and dependable operation of vehicle. This system necessitates timing and control. For the multiprocessor operating system, embedded system, multiprocessor operating systems are also used in embedded systems, which are computer systems that are integrated to another device or product. Gaming system, multiple processor operating systems are used in a gaming system which require a high performance computer to deliver a high quality graphic and audio. Server system, multiprocessor system operating systems are used in a server system which are designed to provide services to clients over a network.
In-depth review and discussion. What is so special about it? First, RTOS or real-time operating system is made to manage jobs with strict deadline. This calls for a system that can respond to input and generate output in the predetermined amount of time. In abundant system where timing and reliability are crucial, such those used in automobile, medical equipment, and industrial control system, RTOS are frequently employed. And second, a multiprocessor operating system, on the other hand, is designed to manage several CPUs and processor. Systems that can demand high performance, such data center or scientific computing, can use this type of operating system. A multiprocessor operating system enables task allocation across numerous processors, which can improve performance and quicker processing. Thus, the key distinction between these two groups of operating systems is their principal area of interest. An RTOS is focused on managing tasks with specific time constraints, whereas a multiprocessor operating system is oriented on managing several processors to boost performance, but it's crucial to keep in mind that depending on the specific need of a certain application, some operating system could be able to support both real-time and multiple processors. Comparison of the characteristic. Key distinction between multiprocessor operating system and real-time operating system. There are the 7 main differentiation of this: time requirement, task scheduling, allocating resources, communication between process, fault tolerance, hardware need, and programming models. The first 3 differentiation. First, time requirement. Real-time operating system is built to handle jobs with specific time needs, and a multiprocessor operating system is focused on managing several processors to boost performance. And next, task scheduling. RTOS resources like memory and CPU time are frequently allotted in line with task requirements. To help them fulfill their deadline, high priority jobs are given more access to resources. And a multiprocessor operating system may manage resources based on load balancing, dividing work among several processors to enhance overall performance, and allocating resources. In an RTOS, interprocessor communication is frequently swift and effective since tasks must interact effectively and reliable to meet timing requirements. And a multiprocessor operating system may manage resources based on load balancing, dividing work among several processors to enhance overall performance. And communicate between processors. In an RTOS, interprocessor communication is frequently swift and effective since tasks must interact effectively and reliability to meet timing requirements. And in construct, interprocessor communication may be slower in a multiprocessor operating system, since tasks may be split among several processors, necessitating communication through a network or other interconnect. Fault tolerance. In an RTOS, fault tolerance is essential since error can cause jobs to run late. High priority jobs must not be impacted by system failures, and the system must be built to recover fast from error. And fault tolerance may not be as important in a multiprocessor operating system because failures can be addressed by splitting up tasks among the surviving processors. And the last 2 differentiation, hardware need. Ensure that timing requirement can be satisfied real-time operating system frequently include specific hardware requirements. To ensure that high priority operating system may be completed rapidly, for instance, or RTOS may need hardware support for interrupt handling. And on the other hand, multiprocessor operating system could need particular hardware, include several CPU, interconnect, and memory control to handle multiprocessing. The last one, programming models. Tasks of tiers with 10 priorities are frequently used in real-time operating system. The make sure that high priority jobs are carried out first, the programmer must explicitly assign priorities to each activity. A variety of programming models, such as shared memory or message passing, may be used by multiprocessor operating systems to manage communication and coordination between tasks that will be executed on several processors.
Hi everyone, my name is Yavina Lau. I'm here to talk about how does its differences about the real-time operating system and multiprocessor operating system. First of all, I will talk about the 8 differences between the real-time operating system and the multiprocessor operating system. The first will go with the task scheduling, processing power, and the processing speed, error handling, power consumption, timing constraints, hardware requirements. The last will be the response time. So now I will talk about the first point, which is task scheduling. For the real-time operating system, the scheduler will be priority-based to ensure that tasks with high priority are completed before the tasks with a lower priority. But for the multi-processor operating system, the scheduler may be based on different algorithms to optimize the resource utilization, as it has to account for the distribution of all tasks with multiple processors simultaneously. Second part, I will go with the processing power. A real-time operating system will be able to utilize the processing power of a single processor. But for the multi-processing operating system, will be able to utilize the full processing power of the multiple processors at once. Third, I will talk about the processing speed. A real-time operating system can only execute a single task with any at one time. It must also complete tasks within a. But for the multi-processing operating system, can execute multiple tasks simultaneously, since providing a high efficiency and the processing speed. So now I talk about the error handling. A real-time operating system must be able to correct the errors with the precision in a timely manner in order to maintain the real-time performance required for all applications. But for the multi-processor operating system can often recover from errors without affecting the whole operating system performance, as it is tasked and distributed amongst the multiple processors. Now this way I will continue with the power consumption. For the real-time operating system, the consumes the less power as only has to execute one task with a single CPU. But for the multi-processor operating system, will consume more power as it has to distribute power to all CPUs for them to all work simultaneously to complete the multiple tasks. Timing constraint. A real-time operating system is designed to handle the task one at one time with a strict time constraint. But for the multi-processor operating system, will be execute tasks in any order as they do not have to complete it within the time constraints. This is not optimized for real-time application. Hard requirements. A real-time operating system usually requires a specialized hardware, as is almost commonly used in systems that require the real-time data or the require a specified function, such as the air traffic control system. But for the multi-processor operating system, will usually require commonly used hardware, as it can serve for many purposes and perform the various tasks at once. So I'll go with the last point, which is the response time. A real operating system must have a minimum latency to produce the accurate real-time data. But for the multi-processor operating system does not have such granted on minimum latency, as it does not need to produce the real-time data. So now I'm moving on this page to talk about what are the pros and cons of the real-time operating system RTOS and the multi-processor operating system. So now we move on this page to talk about the pros of the real-time operating system RTOS. The first part will go with the maximum consumption. The maximum usage of equipment and system resulting in the increased output from all resources. The second part will be task switching. This system allows extremely little time for job changing. For instance, the switching from one task to another on the early system takes roughly 10 microseconds, but doing it in more recent systems only takes about 3 microseconds. So now I'm talking about the third, emphasis on the application. It gives priority to running the application while giving the less important to those that are on the queue. Let's talk about the embedded system real-time operating system. RTOS can be used in the embedded systems such as those used in the transportation and other instructions because the programmers are small in size. Now I move on to the area-free. This type of systems are area-free. Now we're talking about the memory allocation. In these systems, memory allocation is the best managed. So now we will use this space to continue with the pros of the multi-processor operating system. First, we go with the type of parallel processing. Parallel processing refers to the execution for multiple processors, also known as the threads at the same time. Second, is very reliable. The multi-processing system allows for the distribution of processing job among the several processors, because if one processor fails, the work may be handed on to another. This increases the dependability. Third, it reduces the electricity consumption. Due to the need to run the several tasks simultaneously in a single processor system, load is higher, yet its numerous systems are executed in a few times on a multi-processor system. Hence, the CPUs with the server processor use less energy than those with the second processor. So next point, advantage throughput. Throughput is referred to the processor being executed by the CPU is within the time limitation. Therefore, this kind of system will be a greater throughput. So I'm talking the last point, we see the economy. These systems are advantageous from the economic standpoint. It's because the multi-processor system can share the peripherals, additional storage and the power sources. They are less expensive than the computers with a single processor. So now we move on this page to continue with the cons of the real-time operating system (RTOS). The first one will be limited tasks. Few activities are active at once, and they are focused or related little on the few apps to prevent a mistake. So the second part will be the complete algorithms. The algorithms are quite intricate and challenging for the programmer to write on. Third, the trending priority. Setting the trending priority is not recommended since these systems are not prone to switching the tasks. Third, using a lot of system resources. The system resources can occasionally be both costly and of poor quality. So the last point is the device driver and interrupt signal. It requires an override interrupt signal and the device drivers in order to react to the interruption as quickly as possible. So we will this page to continue to talk about the cons of the multi-processor operating system. The first point I'm talking about requires a more memory. Which CPUs needs a memory space since there are several processors cooperating. Second, the deadlock. With one CPU is already utilizing the I/O device, additional processor cannot utilize the said I/O device, resulting in the deadlock. The performance. With one CPU and multi-functions, the workload is distributed among the remaining processors. The task will take a long time to complete, which will negatively impact the system performance. It's expensive. Multi-processor systems are relatively expensive, even if they are multiple more cost-effective than employing many computers. Single processor systems are significantly less expensive to the purchase than the system with a server processor. The last point is the needs a complex operating system. A multi-processor system has a server processor that share the peripherals, memory, hence scheduling the processors and allocating the resources to processing is significantly more difficult in the multi-processor system. As a result, multi-processor computers need an operating system that is more intricate and complicated. So now I will pass it to the next member to continue the rest of the part. Thank you.
In conclusion, these are the contents that we have discussed in this presentation, and we have given a detailed analysis into the topic, while highlighting the need for careful evaluation and consideration in the selection process of an appropriate operating system. Thank you.